Area by double integration for the parabola y equal to 4x minus x square and the line y equal to x. So the area by double integration is having two cases. First is for Cartesian coordinates and then is for the polar coordinates. For Cartesian coordinates, the area bounded by the curves, let's say y equal to f1x and f2x, and the lines x equal to a and b. So the area bounded by these curves is equal to, because the limits of y are in the form of x, I'm writing the limits for y first, f1x to f2x, and this is dy. And then writing the limits for x as a to b, and then writing dx. And now if x are given in the form of y, so this is f1y, f2y, and the limits for y is from, the curves of y as lines y equal to c and y equal to d, then the area is equal to double integral f1y, as these are the limits for x. So writing dx first and then writing the limits for y as from c to d, and this is dy. And now for the polar coordinates, the area bounded by the curves are equal to f1 theta and f2 theta, and the lines say theta equal to alpha and beta. So the area will be, because r is in the form of theta, so this is f1 theta, f2 theta, so writing dr, and then the values for limits for theta as from alpha to beta, and writing d theta, because for the polar coordinates we always write r with dr d theta. So the area bounded by these curves is double integral r dr d theta. And now solving the example, find the area lying between the parabola y equal to 4x minus x square and the line y equal to x. Now how to sketch the region for these two curves? As y is equal to 4x minus x square, let's put first x equal to 0, you get y equal to 0, so this is your point. For x equal to 1, I get 3, so this is this point. For x equal to 2, I get 8 minus 4, that is 4, so I'm having this point. For x equal to 3, I get y equal to 3, so this point. And for x equal to 4, I get y as 0, so this point. So your parabola is like this, right? And the line y equal to x is this. Now to find the point of intersection, this is your line y equal to x and this is your line, the curve y equal to 4x minus x square. This is your curve and this is your line. Now when if you notice here, the limits for y are, because this is y equal to x, we put this limit as a lower limit. And reaching, first we need to draw the strip, as the values of y are in the form of x, so strip will be parallel to y-axis, right? So at this point y is equal to x, so this is your lower limit. Reaching at this point, y is taking the value 4x minus x square, so the upper limit is 4x minus x square. And then for the limits of x, you are noticing that x is varying from 0 to 3. So this is from 0 to 3. If you want to find out the point of intersection, you can just equate these two values of y. 4x minus x square is equal to x. So you get x square is equal to 3x. From here you get x equal to 3. And you put any the values of x in any of these two equations, you get y equal to 3. So the point of intersection is 3, 3. That is this point. This is the point of intersection. Let's say A. Right? So this is how you can find out the point of intersection. And now calculating the area bounded by these curves. So this area is equal to this double integral, because we are having the values of y, the limits of y in the form of x. So I'm writing the limits of y first. From x to 4x minus x square, I'm writing dy here. And the limits for x are from 0 to 3. So this is from 0 to 3 dx. So from 0 to 3, integration for 1 is y, and writing the limits 4x minus x square dx. So this is equal to 0 to 3, putting the limits 4x minus x square minus x. That will give me 0 to 3. This will give me negative x square plus 3x dx. So solving I'm writing here this integral. What is the integration for x square? It is x cube over 3 with negative sign plus 3x square by 2 from 0 to 3. So this is equal to, putting 3 here, you get minus 27, that is minus 9, plus putting 3 over here, you get 27 over 2. So when you put 0, you get 0. So this is negative 18 plus 27 over 2, which will give you the answer around 4.5. This is your answer. Thank you.